Kinematics with variable acceleration, part 2. So in this example we have a yo-yo, and its displacement is initially 0, and as it extends it reaches a maximum displacement relative to where it started, and we have the displacement equation here. Displacement as a function of time. So in a single throw of the yo-yo, why do we have this condition? Okay, so the displacement is 0 right at the beginning, and then the yo-yo extends to its maximum displacement, and then when it comes back to where it started, displacement is 0 again. So let's solve this equation for s equals 0. So s equals 0, now we factorize. There was a t in every term. I've taken a single instance of t out. So we can either continue solving like this, or we can use the equation solver on your calculator to enter this cubic equation and get solutions. So menu option A, polynomial degree 3 because it's cubic, and now we enter the coefficient for the cubic term first, so minus 0.2, then the quadratic coefficient 0.4, then the linear, which is 0.6. There are no constant terms, so just 0 for the constant. So we've got t equals 3, t equals minus 1, which is a nonsense, we can't have a negative value for time, and t equals 0. So this value is valid, so is this, and this one is not. And we can see that t has to be between 0 and 3. So initially t equals 0, the yo-yo extends to its maximum displacement, then comes back again to where it started at t equals 3. So the value of t is in between 0 and 3. Part B, what's the maximum displacement? Now we know that initially the yo-yo is not moving, but when it starts to move, it will eventually come to a stop, and v is 0 at the point where the maximum displacement can be measured. So we have our displacement function. It doesn't matter whether it's a letter x or s or r, it doesn't make any difference. We're looking for velocity, which means we need to differentiate. So v is equal to ds by dt. We need to differentiate this displacement function, and that's s in terms of t, so ds by dt. Okay, so I've done that, and we make that equal to 0 because we know that the velocity is 0 at maximum displacement. And then if we solve that using the equation solver on the calculator, we get two values of t, and this is the valid value, it's positive, this one's negative, so we discard it. So we know that at this particular value of t we will have maximum displacement, and the question did say what's the maximum displacement. All we've worked out is the time at which it occurs so far. So we have the formula for the displacement. We substitute in this value of t, and we get 1.21 meters to 3 significant figures. In this displacement time graph, we can see that displacement reaches a maximum right here on the graph, and that's a stationary point. So that's dx by dt equal to 0 at that point. The gradient is 0 at that point. And the same thing happens again here. The minimum displacement, the gradient again is 0, so dx by dt is equal to 0. And we know that dx by dt is velocity. So velocity is 0 here and here. Now on this velocity time graph, we can see velocity reaches a minimum here, so that's a stationary point where dv by dt is equal to 0. And again velocity reaches a maximum here, that's another stationary point where dv by dt is 0 again, and we know that dv by dt is acceleration, so acceleration is equal to 0 here and here. For further practice, try these questions.